Okay, guys. So 4-7, we talked about sine inverse yesterday, right?
Yeah.
And what do you remember about the domain of sine inverse? Okay, so the domain, the input, has to be between -1 and +1. Okay? What kind of answers, what kind of range do we have with sine inverse? Okay, it has to be between -π/2 and +π/2, and that is where on our unit circle? The right half of our unit circle? Here, the right half, I'll use my left hand and, the right half of the unit circle, yes? Okay, so, kind of stick those pieces in your head, and let's talk about cosine and inverse and tangent inverse now. And we spent all that time on sine, so you've got the basics, hopefully have an idea of what you're doing with the basics. And now it's a matter of just, tweaking them to do cosine inverse and tangent inverse. So notice a couple of pieces of information. Cosine, what do we know about cosine? Inverse cosine has domain of -1 to +1. Notice it even says, just like sine, you're going -1 to +1. And a range of what? 0 to pi. Okay, think, where is 0 to pi?
0 to 180 degrees.
Okay, 0 to 180 degrees, which is what part of the unit circle?
Oh.
The top half. So if I flip my paper for a moment, remember we had these 3 half circles on the back, right? And as we look at these 3 half circles, remember these are the range values. So I'll write this in to remind you, but these are our range values. So the cosine range values are 0 to pi, or in other words, 0 to 180 degrees if your brain needs that connection. Okay, so I kind of warned you guys yesterday that when we do cosine, it's a little bit different type of problem from sine, because sine, it's always a positive or negative angle in that first quadrant. Here, our positive angles are still in first quadrant. What about cosine in quadrant 2? These are going to be the negative cosine values. And so it's not going to be just, if it's pi/3 in quadrant 1, it's negative pi/3 now. We're going to have to use 2 pi/3. And so we'll go through cosine examples, obviously. Okay, so there's some information about cosine inverse. And then, what else is listed here? We have to talk about inverse tangent function. Notice the domain difference this time. Domain is, -infinity to +infinity. So, meaning we don't even really have to check the domain on tangent, do we? It could be anything. And then the range. Notice it's -π/2 to +π/2, which is similar to sine. What's different? Yeah, when we talked about the range of sine, it was -π/2 to +π/2 inclusive, where the pi/2s were included in those and could be values. With tangent, those values are excluded. And so when you flip back here to our visual, again, as a reminder, these are the range values for inverse tangent. And notice it's still -π/2 to +π/2, or if you want, -90 to +90, but it won't actually equal those values, right? It's going up to those values, but not equaling those values. Got it? Okay, so keep those half circles in your brains. And we can go back and look at some examples. So cosine, example A. Oh, and note the directions. Find the exact value, so not a decimal value, without using a calculator. So cosine inverse of negative square root of 2 over 2. Well, if you remember what I kept doing yesterday, I would personally check the domain. Is negative square root of 2 over 2 a good domain value? Yeah. Square root of 2 is approximately 1.4. You divide that by 2, you are below 1, right? All I know is below 1 at that point, which is what matters. Okay, so I have a good domain value. So we have to talk range now. We have to figure out that answer. Cosine inverse of negative square root of 2 over 2. I would forget the negative for a moment, and let's figure out a reference angle here. When does cosine equal square root of 2 over 2?
45 degrees.
Okay, so if you look on your chart, cosine of 45 degrees, or pi over 4, is square root of 2 over 2, correct? Now, okay, let me go to my unit circle for a moment. So, right here, pi over 4, 45 degrees. Notice the ordered pair even tells me, right? Cosine is square root of 2 over 2. Now, we're being asked, though, about negative. When does cosine equal negative square root of 2 over 2? She says 3 pi over 4. Does that make sense? It should. Here's the deal. Do you guys remember how I talked about this yesterday? Think about reference angles. Cosine inverse is where? Cosine inverse is only on the top half, right? Forget the bottom half of your circle for cosine inverse. Positive cosine over here. We need negative, so I now have to go over to quadrant 2. Well, what is equivalent to pi over 4? And equivalent to pi over 4 is going to be 3 pi over 4. Or it's the idea of the reference angle, right? Pi over 4. From pi, if you go back pi over 4, where does that put you? And it puts you at 3 pi over 4. Okay? Notice, what is the cosine value right here in the parentheses, or in the ordered pair? Negative square root of 2 over 2, right? So what's our answer here? 3 pi over 4. And I will say, if you want, we had to think pi over 4, but in quadrant 2. If you want to make a note to yourself, that would be my suggestion of a note, is that we had to think pi over 4, but in quadrant 2. Questions if you have them. Otherwise, move to B when you're ready and start thinking about that. Tangent inverse of square root of 3. Is my domain good? Yes, because the domain of tangent inverse can be anything. So domain is good. So let's figure out a range. When does tangent equal square root of 3? He says pi over 3. Do you guys like that answer? Are you looking at your chart maybe? When does tangent equal square root of 3? And so if I look at my chart, tangent equals square root of 3 at, you could say 60 degrees, but easier to say pi over 3, yes? Well, no, easier to say 60 degrees, but preferred answer is pi over 3.
Will we be able to use that chart during the test?
Yep.
Okay.
Yeah. And in fact, what I've asked you guys, what I've suggested you can do, start getting ready, is take your unit circle and copy your chart onto the bottom of your unit circle. Okay? Because you are allowed to use both of those. So that's, your homework one of these nights is to start copying them over. Okay. You guys okay with B? That was an easy, we didn't have any catches there. Okay, let's move to C then. Cosine inverse of cosine of negative 1.1. Parentheses. So what did we talk about yesterday with parentheses? Yeah, start inside the parentheses first, yes? Now, inside we are just strictly talking about cosine. Forget cosine inverse for a moment. So, do you know the cosine of negative 1.1? Okay. Are we allowed to use a calculator in this problem? No. Okay. So we have to do some thinking here. Now, we say cosine of negative 1.1. First of all, as crazy as it is to think about that, cosine of negative 1.1, negative 1.1 is an angle here, right? When we do sine, cosine, or tangent of something, it's an angle. So when you think of this negative 1.1 here as an angle, and it's not marked degrees, which means it's negative 1.1 radians, do some thinking. Where, as in what quadrant, is negative 1.1 going to be?
Is it, I thought it was 1.
Well, it's a negative number. So if we're talking negative 1.1, okay, so here's what I think. Think about your markings. So this is 0, right? What's over here? This is, we call it pi, but what is pi?
180 degrees.
Not 180 degrees. What is the number value of pi? 3.14. Not what's the coefficient for it, but pi is 3.14. Are we in agreement there? Okay. And I guess technically, if we are here at 0, and we go negative, right? Negative takes me this way. So this is negative pi, so this is negative 3.14 radians. What's this down here when we go negative? So if you start at 0 and you start going down here, what is this angle that we normally call 270? If we were going positive, it'd be 3 pi over 2. Since we're going negative, it's negative pi over 2, yes? Okay, estimation skills. Approximately, what is negative pi divided by 2? Up on part C, I have written down 1.57. But, I mean, we talked about this yesterday, at least in one of my classes we did. Even if you estimate pi to be about 3, 3 divided by 2 is around 1.5, right? Okay, that tells me enough of what I need to know here, because that's telling me that this is approximately negative 1.5. So what would be negative 90 degrees is approximately negative 1.5. Where is negative 1.1? In quadrant 4. I know, that took a lot to get there. And realize, this is a difficult problem. This is not your typical everyday problem, right? Okay. Now, so the cosine of negative 1.1. Okay. We still don't know that value right here. But what do you know about cosine in this quadrant?
Positive.
Positive, right? all students take calculus. So this is positive. Where else is cosine positive? Quadrant 1. And so what is the corresponding angle up here? If down here it's negative 1.1, what is it going to be up here? Positive 1.1. Now, why is it important that we bounce up there? Because we need to be able to talk about this, we need to be in quadrants what? 1 or 2. Okay, so what we're doing here is we're looking at cosine, it was the cosine of negative 1.1. Well, that's going to be equal to whatever the cosine of 1.1 is, which is the quadrant we need to be in. And so what we're going to say here, are you seeing where I'm going with this? Cosine inverse of cosine of negative 1.1 is going to become what? Positive 1.1. Do you remember yesterday? Let me refer to yesterday. Let me scoot this for a moment. I'll come back here. Here's what I need to reference. What was happening yesterday with sine inverse and sine? Okay. If pi over 3 was in a good quadrant, right? So it was pi over 3 in this case. But what about e? Sine inverse of sine of 5 pi over 6. We couldn't say 5 pi over 6 because it wasn't in the right quadrant. So we had to get to the right quadrant, which in this case was equivalent to pi over 6. So what I just took you guys through down here, negative 1.1 wasn't in the right quadrant. So what's the equivalence that's in the correct quadrant? And that was positive 1.1. Huh? Not here in notes. I'm honestly, I can't remember if you've seen any exactly like that in homework or not. You'll definitely see something like what we saw up top in D and E, where you don't have to visualize those as much, right? The struggle with this one is more of a, like taking it all in, putting it all together. Okay? This is kind of the, this is the brain stretcher here. Does that make sense? This is the one to really stretch you. This is not the typical of what you're going to see on the test, though. Okay? It is. I'm not going to lie there. It's a, it's a hard one for me to try and explain there, but I'm trying to get you guys so you have some idea about it. Are there questions I should answer about that one?
So what would be up top of the regular system is negative pi, and then what would be up top?
If you were going, so since they gave us negative 1.1, so we're going this way, right? This was negative pi over 2, so negative 1.5. This was negative pi, so negative 3.4. So if we're going negative, this would have been negative 3 pi over 2, which I'm going to go with approximately 3 plus another 1.5. So it's going to be around negative 4.5-ish. That's a very ish number. Because then when you get over here, 2 pi is 6.28, right? And so that's why I would say negative 4 point something in the negatives. But if we're going positive, it's going to be the positive 1.5. I'm not sure which way you're asking that question. Did I answer it one way or another, though? Okay. Okay. So we talk D. Tangent inverse of 0. Do you have a 0 on your chart? Like, can I say what angle does tangent equal 0? No. These 0 things happen where? The quadrantal angles, right? 0, 90, 180, 270, 360, or what we should more appropriately say, pi over 2, pi, 3 pi over 2, 2 pi, right? Now, tangent. When we look at these ordered pairs on here are what? They're cosine sine, right? So here I have a cosine value, a sine value. A cosine value, a sine value. Do you remember how do we get tangent? Okay, sine over cosine, or y over x. Do you remember learning y over x?
Yeah.
Okay. Cosine is x, sine is y, and tangent is y over x. So when we think about this, and I'll go back to that in a moment, if tangent is y over x, we're looking for, what is 0 as a fraction? 0 over anything, right? So we're looking for some place where what is true? 0 is the numerator, so 0 is the y value. So I need to find some place where 0 is the y value. Well, okay, bring the unit circle back for a moment. I know I keep going back and forth, but I'm trying to make sure virtual and in class can see. So we want to know when is 0 in the y value. So basically we're asking when is sine 0. So when is 0 in the y value? At what angles? 0 and 180, or officially 0 and pi. Now, which answer is the correct one?
It has to be 0, right? Because of the range values of the tangent, it has to be on that side.
Okay. My options were at 0 and at pi. However, which type of problem are we doing? This is a tangent inverse. So tangent is where?
On the right side.
On the right side. This left side, not an option for tangent. So that means we can't use pi, and our answer has to be 0. And this is because the ordered pair here is 1, 0. So as crazy as it sounds, all of that to say tangent inverse of 0 is 0.
Some of these you can just remember.
You could. Okay. One more. Cosine inverse of -1. So when does cosine equal -1?
We don't have it in the chart.
It's not in the chart. So think of it as a quadrantal angle. Zeros and ones are often quadrantal angles in cosine and sine. When does cosine equal -1?
Probably.
At pi. Any place else?
No.
No. Is that an appropriate answer? Yes, because we're talking about
Cosine.
cosine. And what's the range of cosine? The top half, right? So if you think about the ordered pair, -1, 0, and remembering it's cosine, comma sine, well, cosine is -1, and that is happening at pi. And that's okay, because cosine was 0 to pi. That was our range. Okay? Figure out, by all means, I tried to write some notes, put some things on here that when you look back at this and you're trying to figure out how the heck did she do that in class, that you can figure it out. But some of this is hard to write down how we did it. And so that's where you guys are just going to have to come back and ask me, how did we do that one? Explain this one again, and I will gladly do that. Okay, homework that is due tomorrow is page 385, 1 through 20, 23 to 32. And And I'm trying to think, if I'm not mistaken, I'm not sure there's going to be a lot of work to show on these. I mean, some of them there might be more than others. Just depends. There are some calculator required problems. There are some problems that are not calculator. Okay? Yes? Yes. Grab books if you need them. Because I would prefer you be working than not, because we've got about 15 minutes. That is fine.